So the topic is power system stability. In this power system stability, we have different categories of stabilities are there. Number one, this one we call as a power angle stability. Angle stability we call. That is a rotor angle stability. Rotor angle stability. And second category is frequency stability. Frequency stability. Third one is voltage stability. Voltage stability. Now, coming to the rotor angle stability, again this rotor angle stability can be categorized as two types. Two types of rotor angle stabilities. One is transient stability. What is that? Transient stability. Other one is steady state stability. Steady state stability. These are the two categories mainly we have. And again, if you want to see a brief difference in the steady state stability, we have other two types. So we may have static stability as well as dynamic stability. This is called dynamic stability. Almost all we call this is steady state stability only. If you want to go for a small difference, there we have a static stability and a dynamic stability. The dynamic stability is nowadays we are calling as a small signal stability. Small signal stability. This is called small signal. So, what is meant by stability definition? First of all, we want to know that. Generally, the frequency stability we have two categories. One is due to the large disturbance, one is small disturbance. Even voltage stability is also having two types. One is large disturbance, another one is small disturbance. But as far as your competitive examination point of view, in our syllabus we have rotor angle stability only. That's why we are not talking about frequency stability and voltage stability. But as an electrical engineering student, you should know what is these things also. At least brief details you have to know it. If time permits, we will discuss these things also. Otherwise, we have to concentrate more on the rotor stability. So, what are the topics which we want to see here? What are the topics we have to cover in a rotor angle stability? Number one, definition of the stability. Definition of the stability. Number two, power equations. What is that? Power equations we have to discuss. After knowing the power equations, load angle versus power curves. Load angle versus power curve. Power curve. And number three, what is that? Swing equations we have to discuss. So power angle curves, power equations for both salient pole mission as well as smooth cylindrical mission. The power equation we have to see for smooth cylindrical alternator, and also this is for, what is that? Salient pole mission. Salient pole mission. Now coming to the third category, third discussion is, what is that? Swing equations. Swing equations. And swing curves also we have to discuss. Swing equations and swing curves. The fourth topic in this power system stability, coming to the rotor angle stability only, I am talking about all these things. All these points we have to talk about the rotor angle stability. The fourth one is inertia constants. Inertia constants. In the inertia constants, there are two types of inertia constants we may have. One is H, other one is M. How this H and M, if the machines are connected in parallel? How this constant, if the machines are operating in coherent and non-coherent? Those conditions also we have to verify. After the completion of this topic, we have to move into equal area criteria. What is that? Equal area criteria. Equal area criteria. And the last one, the topic may be very important, that is critical clearing angle, and also critical clearing time. What we have to calculate critical clearing, delta CC and TCC. Delta CC is called critical clearing time and TCC is called critical clearing time. This is angle, this one is the time. And of course one more is there, that we have to discuss about the how stability can be improved. What are the methods to improve the stability? Improve the both transient stability and also steady state stability. After completion of all these things, or meanwhile we are going to get some problems on the stability. At least we may have 15 to 20 problems we have to discuss in this particular rotor angle stability in different topics. Generally, the way we have all the topics are very important, because power equations they will ask one question. Normally they will touch the topic. Swing equations several times they give a question. Inertia constant is also more one. And equal area criteria, critical clearing angle, all these are having areas of getting problems in our examination. However, now what is meant by stability? All these things I give an idea. What are the topics we are going to talk in our particular video in this session? What are the topics we are going to talk? Because you should know what we are preparing, what for we are preparing. You see the last 20 years gate questions, if you verify, all the 20 years questions will come under only these particular topics. That's why I am giving one by one. Definition, stability, power system equation for both smooth cylindrical and silent pole, all these things will be there. Now, we want to talk about what is meant by the stability. What is meant by the stability? Just we want to concentrate on what? I told you now, we want to concentrate only on the rotor angle stability. Now our topic is rotor angle stability. Now, what is meant by stability? My question is, what is meant by stability? Stability in the power system. Stability in the power system is the system retains to its normal state or stable state after a disturbance. After a disturbance. Are you got the point or not? Stability is defined as a system, that system is power system, retains to its normal state or stable state after a disturbance. That disturbances may be, the disturbance may be very small, the disturbance may be very large, the disturbance may be very slow, and the disturbance is very fast. If a large disturbance will take place, if a large disturbance takes place with a sudden variations, these type of disturbances are called transient disturbances. This type of stability is called transient stability. And coming to the steady state stability, steady state, slow and gradual increasing of load, there is a changes in the power system. That type of disturbance is called steady state disturbance. To attain the normal state from such a disturbances is called steady state disturbance. Now, steady state stability. This one is called, a disturbance is due to small and gradual. Small and gradual. Slowly load is increasing on the machine. The effect is slow. The effect is small. Slow as well as small. That type of stability is come under the, what is that? Steady state stability. Generally, sometimes you should know the transient disturbance is more severe or steady state disturbance is more severe. No doubt, the transient disturbance is more severe. This is more severe than this one, than the steady state disturbance. Is it clear? Of course, steady state power limit is more than the transient power limit. That is different. steady state power limit, this power limit is more than the transient state power limit. What is steady state power limit, sir? What is steady state power limit? During the steady state stability, how much maximum power it can be handled, it can be carried without losing its synchronism. That maximum power limit, up to what power this stability will be carried out, that type of limit is called a steady state power limit. Generally, if you see load curves, I will tell you later sessions. If you see here, this is the load angle curves we have. We know very well, of course, you may be discussing in earlier classes also. Now, this is what you have a maximum load angle delta. This is the D maximum. This is a P maximum and this is called D maximum. This is the maximum power limit of steady state limit. This maximum power limit is called a steady state limit. Whereas this one, transient limit may be here or like this. Maximum transient power limit may be less than the steady state limit. Because the maximum steady state limit is given by P max is equal to EV divided by X. X is the reactance in the system. This is the maximum steady state power limit formula. Based on this also, we want to solve many problems, especially they will give in a per unit values everything. Sir, now I want to define very clearly what is stability by the human being examples, by considering how the people realize. Suppose your synchronous machine is there. Synchronous machine is operating in synchronous speed. Synchronous speed means we have this is the alternator. Alternator is nothing but synchronous generator. This is the stator alternator. This is stator alternator. We have a rotor here. This is the rotor. Assuming that it is a two-pole rotor. What will happen? Your rotating magnetic field is there. Because three-phase supply you are given. Rotating magnetic field will be rotating like this. As well as your rotor is also operating with like this. Both are with a synchronous speed ns under normal condition. When your rotating magnetic field in the stator is rotating, as well as rotor is also rotating here, the rotor is rotating here, both are operating at synchronous speed. That synchronous speed ns is equal to 120 F by P. The synchronous speed ns is equal to 120 F by P. Sir, whenever the synchronous speed is ns is equal to 120 F by P, under this normal conditions, if you have nothing you did here, nothing is happened, no disturbance, no question of discussion of the stability. Because under normal condition, why should we follow like this? But once if the sudden disturbances happened in the machine, that is, if the load in the shaft, mechanical shaft is removed, load is applied immediately, what will happen? This rotor may accelerate or decelerate. Why? Because this rotor having sudden variations, that disturbance may be small, may be large. Suddenly if the load is removed, that may come under the transient disturbance. Once after the disturbance, again what happens? After some time, your rotor will come to its normal state only. The rotor will come to normal state only. What will happen? It may have, but again it will be attaining synchronous speed, but the rotor may occupy some other place, not exactly at this place. The rotor angle, this between this rotor, stator rotating magnetic field, rotor axis angle may be called as a delta. This is called power angle or load angle. Power angle or load angle. During this power angle or load angle, you don't have, normally it will be constant. Once if the disturbances comes, this load angle will vary. Sir, you are traveling in a bus. You are traveling in the bus. For example, you are in the back seat. You are, suppose assuming that you are in back seat. Better to understand more convenient way. So when you are going in the bus, suppose some speed breaker came in the road. Some speed breaker is there. If driver is not applied the brake during that particular speed breaker time of interval, what happened? The bus suddenly it can slightly go up. It will go up, slightly it will go up. Isn't it not? Are you got my point? Once if it is the bus is up, what happened to your body? Your body is also swinging like this. You may swing like this from your seat. Again, what will happen? So you are falling down into your seat. So whatever the disturbance is there, that disturbance may be transient, may be steady state. If slow disturbances happen, that is steady state. Sudden variations like our bus example you take, that is a transient disturbance. Again what happened? Few minutes you may sit properly, but your sitting place may not be exactly the same position. Your position slightly may changes. In the similar manner, your rotor is also not at the same place of the original position, maybe same place, but most of the cases this position can change. This position can change, but it attains the stability. Only during the your speed breaker period, you may oscillate, you may get the oscillations. You may get the oscillations. But once after a few minutes, what happened? Your body will be normally adjust to your sitting. Again, bus is going to the slowly or fast, whatever it is, you are calmly sleeping or something sitting like that. That is one type of example how the disturbance occurs in a synchronous machine. For example, even myself is here. I am walking like this, under normal condition. Suddenly, in my body, some 50 kgs weight has came. Some 50 weight immediately it has on my body. What happened to my body condition? What happened to my body? My body has to take adjustment to tolerate that 50 kgs weight. My body condition will change. If that 50 kgs on my body for a continuous period, what happened? My body will adjust for that 50 kgs. Again I am getting stability. Again I am moving. But at the time of load is applied, 50 kgs load is on my body condition will change. Suppose on my body if 100 kgs is fallen, what happened? I will fall down. I will lose synchronism. I may not walk. Similarly, if the load is much more, the effect is more, the synchronous machine may lose its synchronism. The power system loses its synchronism. We are trying to maintain always synchronism because the nuisance in the power system is, it is an interconnected system. It is not an isolated system. Suppose Bangalore is there is a grid that may be connected to Pune. Pune is there, that may be connected to Delhi. Delhi is there, Delhi is connected to Bombay. Like that, overall India, the power system is an interconnected network. If the disturbances happen, that may be affecting gradually to one to other. And load, you imagine, what happened? Load is a regular one. You fellow, in the morning you are going to switch on your geyser. And if it is summer will comes in the night, you are using AC. Suddenly you are switch off your AC. And industries are there. They are shutting down the industries. Load is shutting down. Such variations are more in the power system. We want to take care of that. We have to maintain the rotor angle stability as well as also frequency stability and also voltage stability without damaging our equipment. This is about what the introduction of our stability. A large disturbance, sudden variations, that type of stability come under the transient stability. The maximum power, how much power it can be handled by during this disturbance is called the transient power limit. And a small and gradual disturbance of increasing of load or something like that. Such a disturbances are called small disturbances that belongs to criteria is called steady state disturbance, steady state stability. The maximum power limit of steady state limit is this one. This is more severe than this one. This is more severe than this one. And steady state stability can be categorized as a static stability and dynamic stability. In static stability, it is a inherent stability. It attains privilege the stability without aid of the automatic voltage regulators. With aid of automatic voltage regulator, the privilegation is obtained. That type of stability is called dynamic stability. That is a small difference between without aid of AVRs, automatic voltage regulators, with aid of the automatic voltage regulator. Nowadays, in the recent days, what dynamic stability we are calling as a small signal stability. I hope you got some points regarding the introduction of a power system stability.